Nice to have everyone back. It's another amazing opportunity to see and explore R, of course. And today we'll be looking at data exploration in itself. So happy to have you here. My name is Peter Evie, and welcome to another session on R programming. So, building on what we've been working on, we have we've seen how to create sections, install our packages. We've also seen how to import our data set using the import function from the real package. Today we'll be looking at exploring data because you have to, yes, I don't want to use the word to define the word, but we have to really explore our data to see what our data really looks like and how we can make it better. That's the whole sense of exploration, is that like trying to find, to understand how the data is being structured, because without a firm understanding of how your data looks like, you won't know how to clean it and you won't know how to analyze it the best way, because you can analyze a data that is not well structured, right? Because it's garbage in, garbage out typically. So today we want to take time to understand data exploration. Now there are several functions that can help you explore data, right? So we'll be looking at just few of them, but you can go your own way to find certain functions. There's some functions that do similar things, right? But with a better edge. So without so much talk, let's dive into data exploration. When we say we want to explore data, we want to actually look at the dimensions, the structure, the class, and the values in our data set. So there's a package that I didn't add to this sort of load packages, right? And that particular package is called Epikits. This here, Epikits, contains one of the essential packages we have Epikits. So I will great. Now we're ready for our data exploration. So the first thing we want to check basically for in our data set is a dimension, right? We want to check the dimension of our data sets. Looking like a dimension. So I'm always adding comments to my script because it helps me understand. It helps me read it better when I come again. So the function to check the dimension of our data set, dim is the function, and then we can put our data set COVID underscore. So as you are typing it, I will pop or pop the options that are available that looks like a data set, or looks like what you're trying to type. So I can use a tab to select, use the enter. So I will run enter. So it shows me that my dimension is 3 by 9. So what does it really mean? So this means 43 rows and 9 columns. So the first one you see here is the rows, and the second one is the column, right? So there's one unique thing about R is that unlike how we have Excel, we have rows, columns, and we have cell. In R, we have observation, we have variable, and we have value. So in R, your rows in Excel is your observation in R. Take note of this. Your columns in Excel is the same as your variables in R. Your cell, single box in Excel, is the same as value in R. So you may not be seeing columns and rows that much. You see it actually, but the more the one you'll be seeing most frequently is observation. And if you even look at your environment, you see 43 observation, 9 variables. So you will not really be seeing columns and rows like that. You see more of observation, variables, and values. With that being said, so we've seen that we have 43 rows and 9. Right. The second thing we want to say is the first few columns. First few then a function for this is head, head in coin. Right, so head, I'll do the same thing. COVID on. So what this shows me, it shows me the first six rows of my data set. So the default is the first six rows. So it shows me only the first six rows. So I want to see, okay, this is how my data set looks like. It shows me the first six rows. But if I want to see just the first three rows, it's the same. The function is head, the code is head, then COVID underscore row, comma, n number of rows I want, 3, then I run. Then equal to 3 shows me just the first three rows. Still exploring our data. So another thing, since we have head to the first six row, what is the function to show us the last six rows? By exactly tail. We run tail last few rows. So tail COVID run shows us the last six rows. And if you want to see just the, let's say you want to see the last 10 rows, so tail COVID comma n equal to shows us the last 10 from 34 to 43. So if I want to also see the names of my variables or the names of my columns, the function is names. Names, I can now see, and now do COVID. If I run this code, shows me all the names of my variables or the names of my column. And say, okay, these are the things I am looking at. It gives me an idea of what's happening, right? Glad we are moving. So names, let me comment on this in case I share the script. So hashtag names of variables function is names. Now I want to talk about something very important in R, called data types. Now, from our firm understanding or from our background on statistics, there are two kinds of data. We have the categorical data, and where we have the numerical data, right? But they are also subdivided into five distinct types. So the categorical data is divided into three. We have the ordinal, we have the nominal, and we have the binary for categorical. Then for the numerical, we have the continuous and discrete numerical data types. I come again. There are two categories of data types in R. In statistics, basically, not even in R. We have the first is the numerical data type, and we have the categorical data type. The categorical data type is subdivided into three: the ordinal, the nominal, and the binary, while the numerical is broken down into discrete and continuous data type. Great. So in case I want to see what kind of data types are in my data set, right? I can now run the function called glimpse in my data type. Then my data set. So it now shows me epi number. This is the data type. Shows me character. Now we said we have categorical subdivided into nominal, ordinal, and binary. Now, ordinal, let's start from nominal categorical variables or categorical data types are data types that do not exist in levels. Like they do not belong to any hierarchy. For example, names of persons, There's no way I will say John comes before another person's name. They are just names, right? Those do not exist in levels. But when we come to ordinal, they exist in levels. For example, I can say relationship status or marital status I will use. For example, look, I can even say it here, marital status, right? It can either be single, um, engaged, married, divorced, widowed, right? And they exist in layers. You can't be widowed if you've not been single. You can't be widowed if you've not been engaged. You can't be widowed if you've not been married, right? So they follow a particular order, they follow a particular level. Like height, for example, short, medium, and tall, heavy, um, medium, and light. They follow a particular level, right? Cold, lukewarm, hot. They follow a particular level. So those are ordinal categorical variable. Then we have the binary categorical data types are just data types that give you two options, either one or two, sorry, zero and one or two. We have yes and no, true or false. That just gives you two options. That's why they call binary. Two, zero and one, typically. So have those in mind. Then for the numerical, we have the discrete and then we have the continuous. So the continuous are things that are numerical data, numerical numbers that have points, decimals basically, because they are continuous in nature. For example, temperature. Temperature can continue from 37.01 to 37.0001. It's continuous, but we cannot say numbers of children in a household is 2.5. Like you can't say the number of cars that the person has is 3.5. You can't put points to those things, but the ones you can put point are continuous. And example of data types that are continuous numerical data types are, example, temperature. We have age, because age can also be broken down into months, and you can have months as 3.5 and all of that. So age, temperature, we have weight, we have, yeah, anything, any variables that has decimal. We have length, right? We have height. Those are things that are continuous. Therefore, discrete, they are whole numbers. An example is numbers of LGA in a community, number of children in a household, number of cars. You can't have a decimal there. With this understanding, we now have a firm knowledge of data types, and you'll see why this is very important. Now, when we run our glimpse function with our data sets, it shows us a drop down of our variables by this side and the data type in the middle, and then the values in those rows, those particular variables. So the first one here, it shows us epi number. So epi number is just like an ID number. Sex, for example, is male or female, which happens to exist in levels, right? Can either be male or female. Then we have age. So DBL is double. That's another word for double. That's a short form for double. And double is another word for numerical or continuous numerical variable, numerical data type, right? So we have age will also be continuous because it has point. Country, for example, here is showing character. Now, these are just the way that the data set was stored. It doesn't mean that that's actually the way it is, because there are some here that are not as expected, right? So marital status, we said it's an ordinal, not a nominal. So if it's an ordinal, that means it's supposed to be something called a factor, right? So then we also have date. Now we also have date data type as well. I forgot to mention that we also have date data type. They don't belong to either categorical or numerical. They are just on their own as date and vaccines those outcome, right? So this is the normal default. So by running glimpse, I already know that I have to restructure some of my data type. I have to convert. So there's something we call data type conversion. So some places where data type is supposed to be factor and is showing character here, you will need to convert it into a factor from a character. If it's showing date instead of numbers, you have to convert it as well. So that's why exploration is very important. So glimpse helps us to check the class of our check the data types, type variables, variable. Glimpse helps us to do. Now there's another function which helps you to do the function of dimension, names, and glimpse. It's called skim. Skim helps us to COVID as skim help us to what? So skim does a lot of things. First of all, this is what skim gives. So skim code. First of all, skim will tell us the name of our data set, which is COVID raw. To tell us the numbers of rows, which is 43. To tell us the numbers of columns, which is 9. To tell us also the frequency of the variable types. So how many character variables do we have? 6. How many numerical variables do we have? 2. And how many POSIX is date data type? 1. We saw it earlier on. So it now explain them bit by bit by picking the first variable, character. So to show us, to skim through the variables, the character variables, and ask or tell us whether there's any missing value in those variables. So for example, here there are 000 missing. So that means the complete rate will be 1. So if there's any missing here, it will affect the complete rate to be either 0.9, 0.98. So minimum and maximum does not really count for, you know, for categorical variables, for character variables, and all of that. So we have the numeric. So numeric, we have the age and then the weight. So it tells us whether there's a missing, so this one there's no missing, so the complete rate will always be 1 as well. So we have the mean. What's the mean age from this variable? 46.4. Standard deviation. We have P0, P25, P50, P75, P100. And it gives us a caricature histogram of our age, how our age data type will look when we plot it using a histogram. So this is the beauty of Skim. Skim does a lot at once. So instead of doing glimpse, so instead of doing names, tail, dimension, I just come and do Skim. Skim gives me everything I need. And now the last one we want to look at today is unique. Skim gives us a holistic summary data. So unique is one function that helps us to see the values contained in a variable. So for example, if we have a variable called gender, what are the unique values that will be in that gender? Either be male or female. That's speaking for Nigerian context, right? Because we all know that there, there are countless, there's an infinity, list of gender right now in the Western world. But for context here is that we have two unique values that we apply to our gender variable. And we to find out those unique values, right, is when we use the function called unique. So when you use unique like this, put your type your data set, withdraw. But because we want unique to find out the values in a variable, not the data set in itself, because the word unique is even sounding more specific. So we will have to now what subset, look for the variable look for the variable we want to find the unique value in. So how do we do that? How do we locate that particular gender variable from our data set? Now we use dollar sign. Anytime we use the dollar sign helps us to see the variables that are contained in that particular data. And then we're looking for sex. Yes, not gender per se. So when we run this, it shows us that the unique values in the sex variable, sex column, are just male and female. Sometimes the people who are entering the data might put male, female, and they might put things like female with small letter like this, female with capital letter, male like this. Sometimes even typographic error like the ma like this, issues maybe as a result of mistake and all of that. So if you have these examples in your your sex column, when you run this unique, it's going to show you each of these things, because R is um um very character sensitive. Takes every distinct character and keeps them separate. This is how we can do our basic exploration. And then the last exploration that I do prior to my cleaning and manipulate data is I do a TBL summary. So a TBL summary looks like our data. So data is COVID, for example. I'll use the pipe operator with we've explained the pipe operator. If you've not seen the recording, you can still go back, you'll find it. So COVID raw, then pipe it into TBL summary. When I run this code, it actually gives me a table. It's arranged my entire data set in a tabular form. Then I can scroll through it to see things. So I'm going to be explaining. So for example, this is, I want to just add something called labels. So I can see the variables. So the ones that are bold are the variables. So these ones are the ID. These are the IDs, which usually we don't need them. So it's a sex. It shows me that these are the unique values in it. It shows me the age. It now shows me the the mean age, right? And then it shows me the first quartile and then the third quartile. Then we have weights, shows me the same thing. Country shows me the unique, for example, and her. So if I run this here, unique, right? Our data set is COVID raw. I use a dollar sign and I put country and I run. She's going to show me all the unique characters. Then I can even see some certain mistakes. Like Ghana was not spelled well, so it came as a double value. Ghana also, another Ghana here. So Nigeria also was not spelled well and all of that. So I can also see the same thing here. Say Cote d'Ivoire, Ghana, Ivory Coast. We know that Ivory Coast and Cote d'Ivoire are the same country. So in my cleaning and manipulation, I have to turn them to one country. Mali, Nigeria was spelled wrongly here. So so this TBR summary tells me things I need to prepare to clean and manipulate. That's a whole essence of exploration. It's because there's a point called exploration that we have the next step called cleaning. Because you have to see if there's things that need knitting, adjustments before you go to your cleaning pipeline. So marital status, we can also see certain mistakes as well. So married was not spelled correctly. So we have to correct it as well. Then date of onset of symptoms and all of that. So vaccine dose, you can see it was not spelled. We have full, we have so it tells you that, oh, there are things you need to clean in your data set. Outcome was also spelled well. alive or dead. So exploration is one of the easiest part. You don't have to do any magic. You just see your data as for what it is, but you need to explore your data very well so that you can understand what to clean and why you should clean them as well. So this is where we're going to stop for data exploration. Yes, these functions are not just the only functions for data exploration. There are many functions, but these are the basic ones that I use and I feel we'll be using in the course of this training. Thank you so much. Until I come your way next time, keep using R, keep loving R.